proposal sitting in the Bitcoin Core repository right now that could fundamentally change how Bitcoin works. It's been debated for over 4 years. It has passionate supporters and fierce critics. One side says it unlocks vaults, congestion control, and payment pools that could onboard millions. The other side says it introduces recursive covenants and risks losing Bitcoin's fungibility. This is the story of BIP-119, OP Check Template Verify, and why it might be the most important upgrade since SegWit. To get into CTV specifically, let's talk about what a covenant is. In normal Bitcoin, when you send coins to an address, the recipient can spend them however they want. A covenant changes that. It restricts how the coins can be spent in the future. Think of it like a will with conditions. You can say these coins can only go to this specific address next, or spread across these 3 outputs in these exact amounts. It's programmable restrictions on future spending, baked directly into the Bitcoin script. No new token, no sidechain, native Bitcoin covenants. Check Template Verify, proposed by Jeremy Rubin in 2019, is a new opcode that does one thing. It commits to a specific transaction template. When you create a UTXO with CTV, you hash the future transactions outputs, where the coins can go, how much, and when. The Bitcoin network then enforces that the next transaction spending this UTXO must match that exact template. It's simple, it's elegant, and it enables an entire class of applications that are currently impossible or extremely difficult on Bitcoin. Most universally supported use case is vaults. Right now, if someone gets your private key, they can sweep your entire stack in one transaction. With CTV, you can create a vault where any withdrawal triggers a time lock delay, say 24 hours. During that window, you can cancel the withdrawal with a separate key. The thief can't bypass this because CTV enforces the intermediate step. For institutional custody, exchanges, and high net worth holders, this is a game changer. No more single point of failure for billions in Bitcoin. One that doesn't get enough attention. During high fee periods, exchanges batch thousands of withdrawals into single transactions. CTV lets them pre-commit to these batches in a tree structure. Instead of broadcasting a massive transaction during fee spikes, they can space out the confirmations over hours. Think of it as fee smoothing for the entire network. During the ordinals fee mania of 2023, this would have saved users millions in overpaid fees. This is where it gets exciting for Lightning. Payment pools let multiple users share a single Lightning channel factory. Instead of each user opening their own channel, they all enter and exit a shared UTXO pool. CTV makes the exit process trustless. You can leave the pool whenever you want, and the template guarantees your coins come back to you. This could reduce Lightning onboarding costs by an order of magnitude. Instead of one on-chain transaction per user, you get one transaction for dozens of users. Jeremy Rubin, the author of BIP-119, is a well-respected Bitcoin Core contributor. He's been working on this since 2019 and has produced extensive research, simulations, and use cases. But getting a soft fork activated on Bitcoin is intentionally difficult. BIP-119 has gone through multiple rounds of community review, a dedicated IRC channel, and countless Twitter debates. The activation method itself is controversial. Some want speedy trial like Taproot, others want BIP-8 with mandatory signaling. The discussion has revealed deep philosophical divisions in the Bitcoin development community. Everyone is on board, and their arguments deserve a fair hearing. The strongest criticism comes from developers worried about recursive covenants. The concern is that once you open the door to any covenant, you open the door to all covenants, including ones that could enable MEV-like extraction or degrade Bitcoin's fungibility. CTV is specifically designed to not be recursive. It can hash the next transaction but not the one after that. But critics argue that once CTV is activated, it creates a precedent and a technical foundation for more powerful covenants down the road. CTV supports respond with a practical argument. Vaults are needed now. Every day without them, billions in Bitcoin sit behind single key setups that could be drained in seconds. The recursive covenant concern is theoretical. CTV's design explicitly prevents it, and any future covenant proposal would require its own independent soft fork with its own community review. The slippery slope argument, they say, assumes the Bitcoin community can't evaluate proposals individually, which the SegWit to Taproot journey proved wrong. CTV isn't the only covenant proposal. There's Op Vault, proposed by James O'Byrne, which is a more specialized vault opcode that's deliberately limited in scope. There's APO, which enables L2-based Lightning channels with simpler state management. There's TLove for join pool operations. Each takes a different approach to the same problem. How do we add programmable restrictions without breaking Bitcoin's core properties? The competition between these proposals is healthy. It means we're thinking carefully. Of mid-2026, BIP-119 remains an active discussion. It has not been merged into Bitcoin Core's consensus code, but the research phase is largely complete. The activation debate is the bottleneck, not the technology. The Bitcoin community is famously conservative about protocol changes, and that's by design. When you're securing a trillion-dollar asset, you move carefully. But the use cases are compelling, the code exists, and the conversation continues. The question isn't if Bitcoin will get covenants someday, it's when and which one goes first. If you're not a developer, BIP-119 affects you. If it activates, the exchange or custody service holding your Bitcoin could implement vaults. Your Lightning wallet could onboard you with a fraction of the current on-chain cost. The Bitcoin network itself would become more efficient under congestion. These aren't theoretical improvements. They're real practical upgrades to how Bitcoin works for everyone. Understanding what's being debated helps you understand where Bitcoin is going. Dive deeper? Jeremy Rubin's website at utxos.org has the full specification and use case documentation. The Bitcoin OpTech newsletter covers every development in Covenant research. And if you appreciate this kind of deep technical coverage, the Lightning address is on screen to support the work. Stay curious, stack sats, and I'll see you in the next one.